Hi, I'm Robert. I'm the creator of traVRsal, and today I want to show you something brand new. traVRsal is all about natural walking in virtual reality. Playing games today in virtual reality can be super cool. It can create amazing worlds which you indulge in, but there's one thing that really sticks out that hasn't been solved really well, and this is locomotion. The typical means of locomotion today in video games in virtual reality is teleportation. So you point your cursor somewhere, you click, and then the world around you moves, and you're now at a new place, and you can interact in this place, and then you continue from there. And what typically happens is, even if you have a room scale experience, you're standing in the middle of your room, you constantly teleport, and in the end, you haven't moved the feet. You just stand there in the middle and teleport all the time. That's not good. It, for me, breaks the immersion completely. There are two approaches I want to point out. One is redirected walking. Imagine you enter an elevator, you press a button, and you move to another floor. That is cool. That works. Your brain accepts that this is a way of locomotion, and you successfully traverse in the game. Another one could be a cable car, for example, or imagine the Half-Life scene, the beginning when you're standing in a train. This also works. It's a nice immersion. Still, what you don't do in those methods is you don't actually walk. The other topic is to actually really be able to walk naturally in your living room. And for this, we need to do some tricks. The trick that we need here is called impossible spaces, and this will help to create an environment in which a player can endlessly walk. And I want to show you a quick example of how this can look like. In the top left, you see the experience I want to have the player to have. So he is in some sort of underground labyrinth exploring. He only has this play space available, which is very limited. And now the challenge is, how can we make him turn enough corners so that his brain forgets he has already been at a certain point in space. So when you look at the right hand side, you see he's following the blue path, and then there is this yellow, let's call it transition. And when he steps through the transition, which he doesn't visually see, he will actually see a different space than he was there before. And since he turned around many corners, his brain did not remember and count if he should be actually in a different space, and his brain now believes that he can still continue to walk. And this is super immersive. It's absolutely astonishing when you try it, and it really works. You continuously walk around in the level, which is constantly changing, and you have the feeling you really traveled a long distance. I did a implementation of that over the last 8-9 months and released it on SideQuest. It's called Outdoor Dead, and it features 3 different levels. And those levels allow you to traverse a labyrinth. You can be Pac-Man. You can have an escape room-like setting in an ancient pyramid. And all of this is possible with the technology, which I'm going to show you here. And this is all powered by what is now called traVRsal. traVRsal is an engine on top of Unity, and from today on, it's available as an SDK for others to also create levels for others to share and to experience. And the main reasoning for this was that I have only limited capacity. I can create these technologies, but I am not a professional game designer. I'm not a professional artist. And I really want to bring this technology to people to help them solve the hard problems so they can concentrate on really creating something amazing and beautiful. And today marks the beginning of this journey, and I want to show you where we're at. The traVRsal SDK you find here on GitHub, and you can find some guides. So there is, of course, the Outdoor Dead app, which you can try. You have the wiki, which explains how it's working. And we get to this later. There's a level repository. To get started, we go to the releases, And we will see, okay, there is a release. It's 0250. There's a zip file which you can download for PC, and you extract it anywhere on your PC. Also for updates later on, you simply download it again, you overwrite the existing files, and you can continue. So this is the first part which you need, which is in my language called the editor. The second part which you need is a Unity installation. As of today, it's 2019.4, so you can pick any 2019.4 version and install it through the Unity Hub or whatever you like. And the third component is a tilemap editor. The reasoning here is, in order to create levels, we need some sort of means to express where should objects be placed, where are walls, where are certain transitions, and so on. And due to the nature of virtual reality, meaning every player has a different play space, the sizes are not the same, the game should work in a small space but also in a big space, the game needs to adapt. And this calls for procedural description. So traVRsal is a procedural modeler. Sounds a bit strange maybe initially to some of you, but I will show you and you will see the beauty of that. It's really awesome. So using tilemap, we can simply separate the play space that the player has into certain grid tiles. And we can, for example, say he has 4 tiles horizontally, 4 tiles vertically, and they have a size of 50 centimeters, which is then a 2 by 2 meters play area, which is a nice one to start with, to be honest. You can download it for free, it doesn't cost anything, and you install it on your PC. Once you have done that, let's now start and start up the editor. So I've already prepared this here, and voila, this is traVRsal. As you can see, we need to select the Unity project. We don't have that yet, so let's create a new project. Select new project, universal render pipeline. It's important, and for old habits, let's call it hello world. Create. While this is now being created, we can already switch maybe back to the wiki here, and we go to the wiki on the Traversal Sdk side, and this is where you can find all the information around how do you use the SDK, what opportunities, what options do you have, what are the concepts behind it, how is the editor working, what's the installation procedure like. I will walk you through most of the things now, and I really try to be quick. The main part that we are going to do now is to play through the Getting Started guide. And this will give you from top to bottom a very nice overview, I think, on world building, on transitioning to different rooms, on how tiled works, how the integration is working, and so on. Now, once Unity is up, you don't need to change anything in this scene here, but typically I just delete the assets because they're not needed. And it gets rid of those auto-generating lights here. And this actually all you need to do for now. Now we can actually enter the path to the new project. Hello world, we called it. It detects, yes, it's a supported Unity version, and the SDK is not installed yet. We just click here, edit now, and then Unity will automatically install the package from GitHub. If there's a new version available, it will display an update button here. You simply click the update button and it will do its magic, and there's nothing you have to then do afterwards. Once this is now imported, you will see there is a new menu which will appear in Unity, and it will provide us with 2 windows. The first window is the setup window. So we open that. Let's dock it right here. And the first thing that we want to do is we want to create a level. And a level is basically the biggest building block right now, which then the user can download and experience. Let's call it hello world. Create level. And I intentionally made a mistake And just to show you, there is a syntax behind it and some restrictions. So since these level keys will appear in the URL later on and will be the ones how to reuse also assets from other levels, they have to be upper or lower case characters, numbers, and only underscores and dashes. So let's rename that here. They also have to be unique, by the way. And this means at some point in the not too distant future, there will be a registration form of some kind so that level creators can actually request a key to reserve it so that there are no clashes in the whole system. We now see there's a new Hello World level being created. And before we continue, let me do one more setup step. And this is, we go to Project Settings, Traversal Sdk, and we have to enter the path to the tiled installation. And I know it's program file / tiled / this should work. Let's do a quick reload here. Yes, this works. So we see the tilemap editor is installed. It detected our level. It says Hello World. And let me quickly show you what this level now looks like in the directory. It has the most important file in the root. It's the level descriptor, which shows us, has a certain name, description, and it has some, what I call replacements. We get to this in a second. Then we have folders here, and these folders have fixed names. We cannot change them. They have to remain like that. Audio is separated in two folders. You have effects, which are like gunshots, and you have music, which is used for background music. Data is a super important folder for all the level generation. All the tiled files are in this folder. Then we have images, which contains all the images that are used, for example, as the cover image and so on. We have logic, where you can put logic graphs, materials. I think it's self-explanatory. Pieces contains all the prefabs, the objects that you're using in your game. And sceneries contains surrounding environment, which can surround a room, but does not scale with the play space. It's more to give the impression of a far distant environment, which really helps with the immersion. So let's now load the editor and let's see what options we have. First one is we can load the menu, which is interesting if you want to inspect how your level looks from a metadata perspective. And the second one is to load the level directly. So let's start with the menu. And right now it's still using the Outer Dead engine. This will change in the not too distant future. And you see there's already my game here. You have the my game description, and you can open it. And as you can see, you can click on Start, and then we are already in. And with that, we start in what you probably know as the intro scene when you played Outer Dead. The reasoning is, if you create a level, you want the player to start in a specific point. So you don't want to have him end up in a wall or something. So you want to guide him somewhere to enter this first room. And this is what this scene is all about. It will put the portal into the right place so that the next space that you go in is the scene, is the point which you intended for the player to be in. And maybe just how to steer that. So I use the mouse to rotate. I use the middle mouse button to pan. I use the mouse wheel to zoom. So these are all the functions that you need to know initially. Then I use the left and right arrow keys, or AWSD, to actually move between the rooms. And then I'm now in the first room that comes with the SDK. It's an example level, which features an intro room like this, and then there's a maze afterwards. So we go here, you see there's a maze generated, and then we go to the exit. And you might now ask, okay, so where is now the magic which is happening? Let's maybe get to the picture first. So this is exactly now what we see here. So let's say the player walks around the corner. So let's say this is the corner here. And then let's say he walks around, and woo, voila. There he suddenly sees a different room, which doesn't exist on this side. It only exists behind here in the corner, which is the transition. So when he goes now, and he continues, let's go to the next room. Here, he ends up in the labyrinth. He can go back, and then he's back in this room. So the engine is doing all of that automatically. You simply only tell where are the objects located, where are the transitions, and then all this is done for you. Let's now check out quickly the interface. We have a toolbar up here. Let's make a bit more space. You can activate some gizmos. We get to this later. You can highlight also the transitions just to see where these transitions are, so you know where to look at, because they're sometimes difficult to spot. You can have audio muted. You can auto rotate if that is sometimes very good to simply get a quick glimpse at the levels. What is really nice is you can switch to an orthographic viewer, and since this is a tile view, you can now see the grid in all its beauty, and you can really see are all the tiles correctly placed in a way how you want them to be placed, and so on. You can toggle the lights. You can also play the game actually, or have it play. So you cannot really interact right now, but you will be able in the future. And you have certain settings. One interesting setting here is the assign materials. So let's reload real quick. And then you see it's now randomly coloring the rooms. You see there's the red room. Now next one is the blue room. The blue room continues back to the red room, and then to the magenta room, or whatever color, a cyan room. You go to the next one, it's blue-ish. Go back to the blue room, and here's the exit. So this is how the materials coloring works. So let's get the materials back in, because I like that. Then on the left-hand side, you have the layers, which correspond to the tile map. So you can deactivate the ground, you can get rid of the walls, for example, just to see things better, which is actually very nice. I think I love that. You can also see this is not transition. I can turn it off, and it's simply a wall. And I can turn it back on, and there's a transition. It punches a hole through the wall. It does all kinds of magic. So in virtual reality, there's a glitch-free experience, and that's it. In the bottom, you have arrows, if there are any, and warnings. And in the top here, you have also variables. This is a hint already that there's a logic system. We will get to this later. The only current variable is a light. So I can also set this from here, which is the F9 key is just a shortcut for this one. So let's now change something, and let's see how this all works. So the first change that we want to do is we look at the level descriptor a bit more in detail, and this will start up Visual Studio. I personally often use Visual Studio Code for the JSON files because they can auto-format, which is always very nice. I haven't found this option yet in Visual Studio for some reason. They hid it, but anyway, here we go. So we have the level JSON description here. We saw already this one, but now let's go to the replacements. If you look at our level folders, you see there's not a lot of data in here. So what you can do in traVRsal is you can reuse parts that others have already built, or that come from a library that I provide, which is called /base. /base contains many materials, already blueprints for labyrinth rooms and so on. And this is also what you see here. So the labyrinth blueprints, they use placeholders for the textures, which are called wall, ceiling, ground. And I simply now reuse also materials from the base package to assign that. Let's maybe assign a different material. Let's use stone for now. And you will see automatically the whole level changes. It now has different look and feel. And you might now ask, oh, how do you know that it's called stone? So let me show this real quick in the wiki, or in the SDK. Actually, we have the link to this level inventory, level repository. And this is now where this comes into play. These are the real levels in Autodesk, just for you as an inspiration to see how I created those. So the Pac-Man pyramid and the AI takeover, it's called training ground internally. And you also have the base class. And then you click on base, you see the description or the documentation of that. You see the 3 rooms, the mazes, you have 38 objects to be used. You also see the walls here and so on. And then you have the materials. And here you see there are currently 9 materials. I will get this cleaned up later and have a nicer library. But those are the ones which we can use now. So we have bricks, we have stone, and you can also, of course, use your own. And this is what I want to show you now. So the next thing would be to actually create our own material. And let's do this. We go back to the Hello World example. We go to Materials, right-click, Create Material, My Wall, and we give this a nice distinct color. Let's call it it's orange, for example, like that. And what we need to do now here is we go, instead of this base stone, we actually say My Wall. We save that, it will automatically reload, and it will be broken. The reason is that, let's go to the warning, level Hello World has not been packaged yet. The automatic reload works in a way that when you have a JSON file or a text file, the engine can immediately apply the changes. If you change a prefab or material, then Unity needs to convert this to a format that actually Unity understands. And this is a step called packaging. And let's now open the Unity editor again. I forgot to tell you one more thing. You have to click Setup Tags one time when you install the software so that you have the right tags in your hierarchy. Tags are the ones up here. And you see you have an enemy, you have collectibles, and so on. And now we go to the second window. We go to Traversal Publisher. And the Publisher is actually where all your daily workflow happens. So you have packaging options here. Typically, you leave it on intelligent. It will only package the levels which have been changed. In case you are creating multiple levels, you can create those in one Unity project. And the server packaging is only done when you click the upload button. So you never need to do this except if you want to verify something before the upload. So let's now create the package button. And the first time it will take a bit longer because it will validate all kinds of Unity intrinsica here. But as soon as it's finished, you will see the level will automatically reload. And then in full beauty, our new material will be shown. And the tension is already killing me, the excitement. This has been quite a long way to get this right. And I'm really proud to show this to you today. There's a lot of technical stuff happening in the background, which you don't have to care about. The whole reloading, automatically previewing things and so on, it's all done automatically for you. You can really concentrate simply on the things that matter to you. And now you see you have orange walls and you have reached your goal. Now, let's say we want to get our bricks back because the bricks are actually quite nice. We can actually say base bricks. And then this will cause the editor to have only the lower layer of orange and the upper layers are bricks. If you want to say only the uppermost layer should be bricks, then we can say span this across the whole width or height except for the last one. And then we have the level here. And you see this also the labyrinths, they change their colors. And so it starts to shape up a bit and doesn't look so dull anymore as in the beginning. Now, let's get to the next topic. And this is to actually construct something in the room. And for this, we go to the TMX file in the data folder. We open it up, and this will bring up the tiled. And tiled, maybe to explain it real quick, on the right-hand side, you see the floors. So you can have multiple floors in Traversal. If we have some time in the end, I will quickly show you. Then here you have these layers. You have tile layers, you have object layers. And so tile layers are good when you want to paint something quickly, like the ground. Object layers are good if you want to have custom properties. So you can see here, for example, you can only have these custom properties on the layer, not on the object. For the transitions, of course, it's much nicer. Click on the select icon to actually see also custom properties on the transition. We will get to this in a second. You see also on the floor there are some properties, for example, the height. We can make that smaller, save it, and this will then cause the level to be like a child level for children. We can have, of course, also much bigger rooms. Let's keep the initial height here of 2.5 meters, which is a nice one because it doesn't make it too claustrophobic. And then let's look at the middle section, which is much more interesting. So we have the black parts here, which are the walls, those here, which correspond to the layers. So let's now open up here. So we see the walls 2, ground, and transition. This is exactly the same as you see. And in order to paint those, I use the tile set that I provide down here. You can extend this. I will do a session on this in a follow-up video. But for the beginning, I think it should be good to just play around here and get accustomed to how this works. When you go to transitions, the object mode, important is you use snapping. So you can move this around, but then it's placed somehow in between. So if you hold the control key, it will nicely snap. And this is really important. What happened now is I moved the transition. So now the transition is actually on the first wall and not on the second one anymore. So I move it back, and this will actually move the transition back. So this is how this all works here with the transitions. And you can paint the ground. You can do all kinds of magic here. And I encourage you to just play around. Over the course of the next minutes, you will see also how to do additional logic and paint additional parts. For example, let's already start and say, let's create a bit more interesting level. Let's make a solid wall here, and let's put a door in here, which we can then open with a button, for example, so as an overarching story. It involves lots of parts, which are easy. So let's first start with the wall. So for the wall, I click on the wall layer because this is the one which already exists here. And then I select the wall. I click the rotate button up here and place it and press save. And this will actually already fill the whole wall here with a solid wall. Now you might ask and realize already, I'm designing a level here which has 3 by 3 tiles, but the grid here shows 4 by 4 tiles. Here's already some magic happening. The play area, which is per default here, is a 4 by 4 area. Currently, Traversal only supports at minimum size 4 by 4 because there is some issue with calculating labyrinths, but it will change in the future, so 3 by 3 is also possible. This is why I'm designing all my levels with 3 by 3 tiles, if possible, because if people later only have a very small area, they can play the 3 by 3 levels. You can, of course, also have a 5 by 5 level if you design one, but then your audience is much smaller because you need to have people with a big play space. But of course, the big tile set also allows it to do more in the level. So this is why I typically do 3 by 3, and the engine will automatically fill parts. It's very intelligent in many ways. There are some hints which you sometimes need to give because some situations are ambiguous. So let's, for example, look at some properties now. So on the left-hand side for the walls, you see there's like an anchoring. We get to this in a second. You see also the magic walls placeholder here, which now explains how the replacement works. And you have things like connect to ceiling, which is handy if you don't want to, if you want to have only one layer just to judge if the placement works, but don't want to obstruct your view too much. So you see all the transition is only here now. Let's get this back, and I rather turn off the walls here to have this space. Now the next one I want to show you is how to actually work with the scaling and the anchors and what this means. So let's, for example, change the play area. You do this up here with the button. You have 3 different setups. the default setup is with 50 centimeters, which results in 2 by 2 meters play space, which is kind of okay. You can go down in traversal. I tried with 40 centimeters. It's still okay if you're not claustrophobic, but then it becomes difficult. You can also change those here if you want to. Now the second setup is for a large area with 6 by 5 and large tile size, because also when you design objects, you need to consider how they scale inside of a tile. And the third one is a skewed area where you have more like a pipe. Let me simply select those now. So the first one is the big area. So this is now 6 by 5, and you can see the level scaled automatically. And the last one is, just for illustration, the very wide but very thin level. So this is also something which is very important to test, because then also the labyrinths, they will change and they will look much different. And it's always good to have an eye out on if all the anchors are correct and so on. Now, once we've done that, let's now say we want to create a door. We have already a door in here. It's like just a placeholder door there, which you can, let's put this not here, let's put this on an object layer. So we create now, right-click, new object layer. Let's call it objects, and we need to move this into the floor. And I now take this tile. So I click this placement button here, then I hold the control key, click it here to have it placed. It's now above the ground. It's a bit unfortunate. So now we have it here. We can select it and then rotate by 90 degrees. For some reason, the rotation moves this here entirely. Doesn't matter. So now we have the door. I save it, and voila, there we have our door. It doesn't look fancy. It's just for illustration purposes. So as you can see, there's a door, and that's how it works. The interesting part starts now when we want to say, okay, how do we open it now? And for opening it, we can use the button component. And down here we have a very simple button. I place it the same way into the objects layer. When you have these red areas, those are the ones facing the player. So now it's the wrong way. I have to rotate it, let's say 180 degrees. And then I move it up, holding control key, and save it here. And then we have a button down here. The placement is a bit off. So if I select the button, add a custom property, let's call it Y of type int. And we say it's on 2. This will move it up to a more reasonable level. So now we have the button, and now we need to connect those two things together. There are multiple ways how to do logic. The original and most easy way is probably to use the variables. And let's give this button the variable door. And let's also select our door and also say this is variable door. And now we save that. And what will happen is when we go to variables, we see a new variable now. And when we click it, the door is gone. Open, open, closed, open, closed. So the button would trigger this variable, and it's the same as if I now click here the variable. So that's quite magical. So we have our first door, it opens when I have pushed a certain button. The button, now you can think already creatively, the button doesn't need to be next to the door. It can be somewhere totally else. You need to maybe find the right door and so on. So there are so many opportunities already by simply having these variable connections. Now let's get this a bit more interesting and say we don't like this door, we want to create our own. So we go back to Unity, and inside Unity we go to the scene, we go to game object, 3D object, cube. You can use Pro Builder, which is a nice tool, which is also free. Just for the time being, I will now create such a cube, scale it a bit just to make it reasonable, and then just use it as a placeholder. So go for it. So let's see how this looks like. Let's turn on the grid. So typically it's good to have the grid in maybe a tip here, to have the grid on 0.5, because this is the basic tile size in traVRsal, and it helps you to actually then place the door. Now the next thing that we need to do is we need to create a prefab out of it, and the first thing to consider now is where's the pivot. Currently it's in the center of the object, which is not the default setting of traVRsal. traVRsal expects the pivot to be in the lower left front corner, and this is easy to fix. We simply create another object, we call it my door, we put the cube under it, we reset this one. That's nice, it's already working. We go to pieces, let's create a prefab out of it right now. Then we go here, and we can actually now move the cube and have the alignment correct. And I think where we want to move it is something like the middle of that. So it's 1 and 0.025, I think it should be. And if we now check the my door arrow, then we can see, yep, the pivot is correct here at the front. We have now a door, it has a bit of a thickness, which is nice. We go and we have it saved in the pieces folder, and then we go back to here, and we actually replace the type here with our with my door. We save it, and voila, it's broken. Why? Because first of all, we didn't package it. So let's go to the errors. The level my door doesn't exist. Okay, so we go back to hello world. We click on package, save, yes. And once it's reloaded, we will see the door is there. Here's our door, which we just created. But, and now we have to be careful, the variable doesn't work anymore because the pre-made logic that was on the other door doesn't work here. So it's not hiding all the objects simply by setting a variable. That was custom logic. And also what we see is if you now deactivate the objects, somehow there's one tile missing in the bottom, but the others are still there. So it's really not, the door's not punching a hole into the wall for some reason, which is a feature of traVRsal, by the way, but only in the bottom. And the reason is that we did not tell traVRsal this is an object which has a height of 4. It thinks it has a height of 1 and only punches a hole in the bottom. This is easy to fix. We go to the where do we go? We go to the object descriptor here in the level, and we add a section here, and we call it I have to cheat real quick. Call it object spec, object key. Okay, so we go to the create an object spec. It's an array. We enter a new one. We have the object key. At some point in time, this will become like an editor inside of Unity. For now, you have to simply live with it for the time being. But it's rather easy to do. So you have now my door. Height 4, and that should actually do the trick. Now let's repackage this. Not yet, I forgot something, I guess. Let me quickly check in the level again. It's a plural. So there's no validation yet. If you misspell something, this will come. But now you see all the tiles are gone. I can disable the object, and voila, we have a hole punched in the wall. I think I will also leave in this segment about how I didn't remember the section, because then you also know how to find your way around. You can simply look into a different level, how it's done. I looked into Pac-Man. You can look into any other of my levels, and they typically use all of the components. So how do we wire up now the door with our variable? And let's use multiple methods. Let's say the first method that we want to use is the variable way. So I will add a component, and what I want to show you is there's the scripts folder here, there's Traversal Sdk, and they have a whole bunch of logic components already right in here, which you can use in order to actually do something. You have the animation trigger, which is a nice one, and let's say we want to move it up by 2. We want to have a duration of 3 seconds. That's nice. And now what you need to know is this is a trigger script which listens to a variable. So we need to add a variable listener in addition, which is calling the reactors. So this is a reactor to a variable. So this is what this all does. And if we save it now and repackage, then we should already see an effect. And we go back to the variables. We click on the door. We unpause, and voila, the door moves up. If I deactivate it, the door moves down. Isn't this cool? Now, I want to show you a second way how to do it. And this is, we delete this. So this is not a pre-made way how you can use the components that I created, but you might get into limitations, like if they're not enough, or if you want to have a different behavior and you want to get a bit more low level. And this is where a node-based graph is super helpful, and I want to show you how this works. So we go here, we use one of the 2 supported graph types. The best graph that you can use is flow canvas. So I have flow canvas support in the Traversal engine. This is a commercial product which you have to purchase. So if you're getting professional and you want to sell your level later, maybe it's worth to get this flow canvas. I have made a alternative version called XNode Graph, which is also quite powerful already, and I want to show you what it can do. You go to Create, Traversal Logic Graph. You can give it a name. Let's call it door. And the beauty is you can then reuse those assets which you create here in other doors or in other animations. And it will open up a node canvas. And this node canvas, when you right-click, you have certain things. Let's say an event is on variable change. Nice. So we have the door, which we want to listen to. And then when it changes, you can drag it out. You can say, okay, I want to let's say flow. I want to switch on the condition and say, okay, if it's true, if the variable is true, it should go up. If it's false, it should go down. So of course it's the same variable, so the condition goes there. And then what should happen is we want to have a position tweening. It will use the current object as the transform, so we don't need to do that. Let's say we want to go up to, let's say, also 2 over the duration of 3 seconds. That was good. Relative is always good to set it. And if it's false, we want to go down, position tweening to -2. Maybe for drama, let's make it a quick way back. Do it like this. And then we should not forget to assign it actually. So we go there, we drag the door into the logic graph, we save that, we package it here, and then let's see what happens. So we remove the other components. We still now have the variable here. We click the door and it moves up slowly, whoop, and it moves down quickly. So it now executes this graph depending on what we do here. And the beauty is you can now do so many things. I will add tons of nodes in the future. So you have calculations to add and multiply. You have any type of wait and delays and so on. You can, for example, also wait 2 seconds and then only open the door. You can compare all kinds of stuff. You have events which will increase, for example, when you trigger something and so on. And you have some initial movement of objects, and there is much more to come, of course, in the future. The important part is this works. And it works quite nicely and fast. Now, the next part is when we switch the level, there's a labyrinth. So I want to show you how those labyrinths are created. To do that, let's go to the TMX file again and select the transition. On the transition, you see a couple of interesting attributes. One is the maze rooms. These are the rooms which are supposed to be used. So when you look at the blueprints again, you will see in the base horizontal maze, this is the blueprint. The green parts mark the maze. So if I go here and I hide the maze layer, you see this is the cutout part. It exactly resembles the room blueprint which I have here. And the maze, of course, adapts to the available place size, and it will create a maze, and you can then use it. You can steer in the level here how many mazes you want to have. So, for example, you set it to 5. This will mean that you now have more rooms, and you simply have more mazes now. You see? So let's put it to 2 again. And then you say, what is the target room? So you can design a second room and go to it, or you have the special variable exit, which means the maze will lead directly to the exit once you have reached the end of the maze. That's how you create mazes. You have also a second procedural element, which is called a path. When you go to the pyramid level, you actually see there's a path above deadly spikes. When you fall down there, you're dead. And this is also supported to create paths between objects which are randomized. Now, our level is still a bit empty. How about we put some items in here? And this is where spawning now comes into play. Spawning happens again in the level descriptor, and it's very easy to do as well. So let's say we create a spawn rules section, and as you can see, you can have many spawn rules. Let's create the first one, and let's call this fungus. So let's put some nice mushrooms here in the level, just because we can, and also just because we have the object already, and we simply define what object should be shown here. Let's reuse something from the pyramid level. Fungus. We save that, and let's see what happens. As you can see, it will download the pyramid level now because it's the first time we use it. So it's automatically fetching this now from the server. And once that's done, voila, we have now mushrooms in our levels. We have 10 mushrooms in total because that's the default for the spawn rule. And it's spread out all over the level. So 3 here, there are 3 here, there are 4 here, which totals 10. Cool. We can spawn with one spawn rule also multiple objects. If we say, for example, we want to have a bit of a variety, we want to have 2 different objects spawned, which total, of course, 10. You see, you have now this mushroom and this one. It doesn't look too much different, but if you look closely, you see there's a difference. These are red ones, these are dark ones. Cool. Now, the next thing I want to show you is how restrictions work. So currently they're placed all over the place. Sometimes it's nice to guide the player a bit, and I personally like to put things in dead ends, so the player early on knows it's a dead end, and maybe you also have a bit more freedom to put something there because you have more space. It doesn't obstruct the corner and so on. So let's do this, and let's say we want to have it in every dead end. In order to do this, we need to change the placement logic, and typically or initially the amount type is total, but we now set it to probability, and we say the probability is 100. So every time it should place fungus. So let's not use the restriction for now. Let's just use the amount type probability, and you see it's now fungus is everywhere. Nice, but this is not what we intended. Let's now put in the restriction, and the restriction is again an array, so you can have multiple restrictions, and the one I want to use is dead end. And I save this, and what happens now is we'll reload, and you see it's only in the dead end. So it goes around the corner, dead end, fungus. Same here, I guess. You have here a bit of ambiguous situation. You have here dead end, fungus. Here, dead end, fungus. How are the dead ends identified? Let me show you the gizmos. When you press the F1 key, you actually have a nice overlay which you can use. And let's start in the beginning. So this is the play area, the red one here. Let's pause the game. Not on the light side here. So here, when we look here, we have the play area which is red. We go to the next room, and here you can actually see it will paint as gizmos the walls it detects. So the red lines are the walls. There are no walls here, so it's gray. They have the nav mesh also displayed here, so you know where objects can walk. And when you go here, you actually see, okay, this is a dead end because there's a cross. And what I also want to show you, there are the green arrows, which show this is the path forward towards the end of the level. The small rectangle means there's a floor, and the round circle means there is a ceiling on top. This is interesting for other placement rules, for example. The green one means there's a transition down here. You can also highlight the transition if you want to. And if you now go to the next level, we see, okay, it continues the green arrow, and the yellow ones is the way back to the beginning. You can do some neat things with those restrictions. You can also place objects now along the correct rotation. So you can say, I want to have a target which faces the player because it faces the direction. This makes the level much more harmonic in the end. You also can react and say, if I'm 10 steps away from something, then something should happen, or the audio should be more quiet, and so on. So this is something that will come in the near future. So the corners are detected. There's also a rule for corners, so you can place fungus also in corners, and so on. Then there are some special areas which are white, and these are the ones where no spawning will happen because these are unreachable areas. Why is it unreachable? Because the player will walk through a transition first and then move somewhere else. And that's basically how the gizmos work. So I can deactivate them, activate, deactivate, however you want. Now, the next thing I want to show you is how to use now audio. Audio plays a big role. You want to have music here in the background. Let's unmute here. So as you can see, if I reload the level.
The portal is now open. Step through the correct side to begin.
We have the default intro voice, which comes with traVRsal, but then no other sound. And now let's add some music, and for this we go back to the to our room. The music is per room, and if you want to change the music, you simply add music to another room, and it will then crossfade into the new music. I go to the map properties, which are the room properties, and we see here there are some ones already entered, like something we will not tackle today is self-moving agents, like enemies that move through the level. You can block them from reaching this room, so you have sort of a safe zone available. But for now, let's simply create here a music property, which is a string, and we want to reuse the music from, let's say, the intro theme. So we go for Nordic title.wave. We save that, and it will reload the level. And
The portal is now open. Step through the correct
the
side to
music.
begin.
Beautiful. The second type of sound that we want to support is when you, for example, open the door, it should play a sound that the door is opening. And to do that, let's create a sound effect, and we go back to the level. We go here to the Xnode graph.
The portal is now open.
Let's deactivate the sound for a second. And there we again add components. One is the audio player. Then we need since it's a reactor, we need to have the variable listener again to call the reactors. And then we need an audio source. So we have the audio source. The audio sources will automatically be added to the mixer, and depending on where the sound effects come from, will either contribute to effects or music or voice. Deactivate the play on awake, because that would be strange in this case. And we then drag the audio source up here, and now we just need an audio clip. And if you have one, just use that one. I just go to the asset store real quick, and there is one very nice free library which we can quickly use here now. So I do a quick search, 44.1, and this is the bundle that I was talking about. I simply import it real quick, and it contains a number of sounds which we can now reuse in our game. Let's close this again, and let's go here, volume 1. There are all kinds of nice ones. I found the church closing locking. I think that was a nice one. So let's use this one, audio clip. Now we save it, we package, and let's see what happens when we activate the door. It's reloading. Go to variables, door. Beautiful. Door opens. Click again. Door closes. And this is how you add audio. Now, the last part for audio which I want to show, and then we are already at the end of this quick introductory session, is if you want to have the artificial voice also say something, which is quite a nice effect, and you can use it to all kinds of means. Let's go to the level descriptor again and add a speech section. And the speech in this case should be, it's event-based, so it's the global event queue here. And when we say the event we want to listen to is the variable on. So if something turns on, we use the key is door, and then you simply say the text. And let's say it's dangerous to go alone. Take this, and it's already a hint that first of all, it's a nice saying from the meme community, but it's also a hint maybe you don't have to play those levels alone all the time. Who knows? So let's save that. It will be reloaded automatically. And now if I open the button, I open the door, listen very closely, activate audio again.
It's dangerous to go alone. Take this.
Amazing. There, it's talking to us. It only does it one time, so you don't have to be worried that it's constantly talking. And this concludes our first session here in the Traversal editor. I hope you liked what you saw. Initially, I promised I will show multi-floor environments, so maybe let's do this also real quick. And because it's so quickly to do, we go back to the floor. Let's simply maybe duplicate this floor, and let's call it underground. The important part is the stacking order, so you need to have this actually below the first one, otherwise you will get an error. We don't need all this stuff. We just need the ground. Okay. Let's save this. Let's see how it looks like. So it's now reloading, and you see, voila, we already have here the the floor. So we have this room now which we designed. It doesn't do much yet. The reason is that we cannot reach it. So there's maybe we should have a hole here in the bottom. So let's create a hole in the first floor. Let's simply punch it through, and let's say we remove this tile, we save it, and then when you look in the editor, voila, there you have a hole in the floor, and now the player can drop down here. You can have some deadly spikes down there, or you can have a meaningful way to find something, and then maybe you get up another way, or you only go down. So all those things are possible, and that's how it works. And I hope you like this, and I hope it sparks your creativity in what you want to do. And I would really look forward to now having discussions on what kind of logic do you need, what would be nice to have in addition. Let's join the Discord or come to the Discord and discuss there. You find all the information in the SDK actually. When you go there, you find this information down here. The Discord server, there are some limitations which continually removed. You have the level repository to learn from. You can go to the training ground, Pac-Man, or there are lots of stuff with artificial intelligence here, moving through the walls. You have damageable objects where you can destroy something, you can collect something, and so on. So there's so many things which you can do. Have fun with this first version. I'm personally super happy I reached this point, and looking forward to all the wonders you come up with. Thanks a lot and have a great day.